All right, let's look at the notes for section 5-3. In this section, we're going to see a lot of vocabulary here. We have got perpendicular bisector, angle bisector, altitudes, and so forth. Let's go with the perpendicular bisector of a triangle. This is obviously a triangle. Perpendicular bisector would be 90 degrees right in the middle of one of the sides. So I'm going to draw this line that I'm just guessing that this is the middle right here. And it needs to be 90 degrees, so I'm going to just draw this 90-degree tick mark there, tick on the left, tick on the right. So this line would be the perpendicular bisector. Pay attention to the fact that it doesn't necessarily start from this vertex. There will be other type of terms that start from the vertex, but this is the perpendicular bisector there. An angle bisector of a triangle, well, there's three angles, so there's three potential angle bisectors. I'm going to just draw one from this angle. It's obviously going to split this angle here, and I'll draw that line. This line would be the angle bisector, and I'll put a tick there and a tick there. All right, so this is the perpendicular bisector. This is the angle bisector. Let's look at an altitude of a triangle. An altitude starts from the vertex, from the highest point, and you are 90 degrees with the base here. So I'm going to go straight down here and just draw that 90 degrees. So this would be considered the altitude. Sometimes that altitude is denoted with dash lines. So you might have the same exact picture like this, and then they'll put dash, 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 dash lines like that. And the reason why they do the dash lines is to not get you confused like there's meant to be a triangle here to the left and a triangle here to the right. The dash line is there simply to say here is the altitude or height. Notice the difference between an altitude and perpendicular bisector. An altitude comes from the vertex, the corner. Perpendicular bisector, do not try to force it from the corner because then you are not necessarily 90 degrees when you bisect it in the middle. This guy is not split left and right being equal. It's just 90 degrees. A median from a vertex goes from one of the corners to the midpoint, and so I'm just eyeballing it. I'm going to say that's the midpoint. So this right here would be the median. It's not 90 degrees necessarily, but it is left is equal to the right. Okay. A couple more vocabulary words here. Concurrent lines is three or more lines intersecting at one point. Intersecting at one point. So I'll just quickly draw up a visual of it. There's one line, two line, and three lines. And we would call all three lines concurrent lines. Alrighty, a centroid is the point where of concurrency where the medians meet. So I'm going to just draw this as best I can. I'm going to draw a triangle there, and I'm going to draw three medians. So that means I'm going to, from this corner, go to the middle here, tick, tick. So that's one line. From this corner, I'm going to go, I'm just eyeballing it, double tick, like that. And then finally, from the final corner, I'm just eyeballing it, 1, 2, 3 ticks, 1, 2, 3 ticks. And as best I can, I'm just doing that like that. So this point where all of them meet, and they should meet at a point, that is called the centroid. Centroid, where the medians, these are three medians, meet. All right, there is one little baby formula based on this. This centroid splits each of the three medians a certain way, and that's going to be this next section here. The medians of the triangle are concurrent at a point at 2/3 of the distance from the vertex to the midpoint of the opposite side. So that's really confusing here. I'm just going to fill this out. DC, which is D to the middle area, is 2/3 of the way D to J. I'm going to use some numbers here. This might be, let's go with 6, and this would be 3. So 6 compared to 9, which is 2/3. E to C is 2/3 of all the way across EG. F to C is 2/3 of all the way across FH. Let's put in some other numbers here. Let's say this is 8. This would be 4. It's basically broken into 2/3 on top, 1/3 on the bottom. 2/3 from the vertex to that centroid, and then 1/3 from the centroid to the side length. Okay. Let's go with this next grouping here. The altitudes. As we mentioned, the altitude is basically the height. It goes from the vertex straight down 90 degrees. Now, depending on the triangle, these altitudes can be in different places. If you have an acute triangle where every angle is less than 90 degrees, the altitude is inside the triangle. So I'm going to draw it with this red dash, 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 dash line, 90 degrees. That's the altitude. If you have a right angle, the altitude is a side length. You go from the highest point straight down 90 degrees, and it literally happens to be this red line is the altitude. It's also the height. It's on the triangle itself. And if you are an obtuse triangle, the altitude can sometimes be on the outside, depending on what side you're looking at. I'm going to take this guy here. You want to be 90 degrees with the base. You don't try to force it inside the figure because that's not 90 degrees. So sometimes the altitude will be outside the triangle. So 1, 2, 3, 4, and I literally have a 90 degree, and you'll see the picture look like this. Like this base goes on, this ground goes on forever, and the height is outside because this is an obtuse triangle here. Okay, but this dash, dash, dash line here is considered the altitude. The altitude, the altitude, from the highest point straight down to the ground, highest point to the ground. All right, let's go over the last group of terms here. We have two words here, circumscribed about and inscribed in. A circle is circumscribed about a polygon. A polygon, basically, the polygon, whether it's a triangle or a four-sided figure or a five-sided figure, the circle is outside the polygon. If you say a circle is circumscribed about a quadrilateral, that means you would see a four-sided figure inside this circle here. The circle is outside the polygon. This is circumscribed about. Okay, and you will be touching the circle in 4 spots if you're a quadrilateral. This is not circumscribed about. Okay, that's just a four-sided figure that is inside a circle. When you use the word circumscribed about, you are literally touching it in 4 spots. If I say the circle is inscribed in a triangle or a four-sided figure, it doesn't really matter. The circle is inside that triangle. And so it would look like something like this maybe. I said a triangle, so I'll draw a 3-sided figure here. And the circle is inside the triangle. It would hit it at 1, 2, 3 spots. So inscribed, the circle inscribed, the circle's in, circumscribed about a four-sided figure, so it's on the outside. Okay, those are the main vocabulary words for section 5-3.